Okay, here we are doing question number 2. We're talking about burning atoms along with stoichiometry. Write and balance the burning of aluminum metal in oxygen gas. So aluminum metal is just an element, we give it a 0 charge. Oxygen gas is just an element, we give it a 0 charge. Okay, now they both are not excited, so they got to get excited. Aluminum's going to go up to Al plus 3. Oxygen's going to go down to O minus 2. We're going to get Al2O3 as our compound. Now we have to balance it. Put a 2 here for the Als. There's 2 and 3 O's, so we're going to do the 3, 2 switch, which is going to make us change the Als to 4. How many moles of Al are needed to react with 0.34 moles of oxygen gas? So the chemicals in my recipe are Al and O2. The molar mass of Al is 27 grams of Al for every 1 mole Al. The mole ratio between Al and O2 can be found from the balanced reaction. That's 4 to 3. So there are 4 moles of Al for every 3 moles of O2. And the molar mass of O2 is 32 grams of O2 for every 1 mole O2. That came from the fact that 1 O is 16. You multiply it by 2 and you have 32. So let's decide what factors to use. We're always going to use the mole ratio factor. If I see the word gram in my problem, I will be using a gram factor, and I do not. So I will not be using those. Feel free to jump to that immediately if you do see it later on. So in the problem, we have 0.35 moles of O2 right here. I'm going to set up my crisscross. Moles O2 on the bottom, and I'm going to go search for moles O2. Okay, there it is. 3 moles O2, and it's related to 4 moles Al. So I'm going to take 0.35, I'm going to multiply it by 4, and I'm going to divide it by 3, and I will have my answer. So this is going to cancel. 0.35, I'm going to multiply it by 4, and I'm going to divide it by 3. And I'm going to get my answer in moles Al. Again, I do not have a calculator with me right now, so I do apologize about that. Setting up the crisscross is by far the most important thing. Question number 2. Burning atoms and stoichiometry for you to do. So here we go. Solid lithium, 0, plus nitrogen gas, boom. Neither of them are excited, so they got to get excited. This is going to make Li3 and 1, and that came from the charge switch. Putting a 3 here, a 2 here, got to change that to 6. Alright, how many moles of N2 are needed to react with 1.5 moles of Li? So N2 and Li are here. The molar mass of N2 is 28 grams of N2 for every 1 mole N2. That came from the fact that this is 14 times 2. The mole ratio between Li and N2 comes from the balanced reaction. It is 6 to 1. So 6 moles of Li for every 1 mole of N2. And the molar mass of Li is, I don't have a periodic, it's either 9 or 7. I'm going to go with 7 grams of Li for 1 mole of Li. I could be wrong though. So, crisscross. I'm starting with 1.5 moles of Li. Do I see moles anywhere else? I do not. Or do I see grams anywhere else? I do not. So I'm only going to use the middle ratio once again. Moles Li on the bottom, and I'm going to go searching for it. There it is. So in this one, this part's going to go on the bottom. No big deal. You can always flip these around however you need to. So it's going to be 1.5 divided by 6. And that's going to be moles of N2 in your final answer. Moving on to question number 3. Okay, in this case, we are going to do some stoichiometry again, and then we're going to do some gas problems. So, write and balance the reaction above. 2, 2, 1, 1. So I'm going to put a 2 here, and I'm going to have to put a 2 here, and a 1 here. How many moles of oxygen are produced? 20 grams of H2O decompose. H2O is decomposing because one thing's breaking up into two things. So it's really happening in this reaction. So I have oxygen gas, and I have H2O, and the molar mass of this is 32 grams of O2 for every 1 mole of O2. The mole ratio between oxygen and H2O is 2 to 1. So there is 1 mole of O2 for every 2 moles of H2O. It doesn't matter how you write this in this part right here. And the molar mass of H2O is 18 grams of H2O for every 1 mole of H2O. Okay, so the crisscross. We're starting with 20 grams. Okay, so we have grams in the problem. We're always going to use this middle ratio. We have grams of H2O, so we're going to have to use this one also. But we do not have grams of O2, so we do not have to use this. So grams of H2O on the bottom, and I find it right here. 18 grams of H2O for every 1 mole of H2O. Done. Move over to the next one. Mole of H2O on the bottom, and there it is right there, 2 moles of H2O for every 1 mole of O2. So 20 divided by 18 divided by 2 is going to be our answer, and that's going to be moles of O2. Again, you're going to take 20, you're going to divide it by 18, and you're going to divide it by 2 to get our answer. Okay, so this next problem then says, all right, use your answer from B to calculate the pressure of 2.5 liters of oxygen gas at 20 degrees Celsius. So when we were calculating energy, we used E equals MC delta T. When we're dealing with pressure, we're using PV equals nRT. We've got to rearrange that for P, which will excuse me, be equal to nRT over V, and we are just going to plug into that. So let's list everything out over here first. N is what we solved for, moles of O2. R is the ideal gas constant, 0.0821. T equals 25 degrees Celsius plus 273, which equals 293 plus 5, 298 Kelvin. Always convert your temperatures to Kelvin. And volume is 2.5 liters. So we're going to plug that in. We're going to take our value here, sum moles of O2 multiplied by 0.0821 multiplied by 298 Kelvin divided by 2.5 liters is going to be equal to our pressure, and pressure is always reported in atmospheres. Simple problems. I apologize, I have not been able to line that up a little bit more clear for you. Okay, let's start this one. I'm going to have to stop it in about a minute. Write and balance the reaction below. 1Al, 1Al, 3 Cls, 2 Cls. I'm going to do the 3-2 switch. There it is. How many moles of chlorine? So we know that Cl2 right there is here. And AlCl3. There it is right there. We're going to set up the molar mass. This is about 70 grams of Cl2 for every 1 mole. Cl2, the mole ratio between Cl2 and AlCl3 is 2 to 3. So 2 moles of Cl2 per 3 moles of Cl2 for every 2 moles of AlCl3. And the molar mass of AlCl3 I will get to in a sec. Take care.